Okay. So in today's class, we discuss solving a linear first order partial differential equations. See here. So this linear first order differential equations are known as commonly known as Lagrange linear equation also. This is another name. So this will be in this form like capital P into small p plus capital Q into small q equal to capital R. Here small p, small q means we know very well that small p means dou z by dou x, small q means dou z by dou y. Okay. So suppose here PQR functions are there na. So here PQR suppose our functions in terms of x, y, z means that is that partial differential equation is known as quasi-linear. Suppose PQR independent of z, that means PQR only in terms of x and y only means they are known as linear. Okay. And we are discussing first order differential equation. So suppose the given PDE in this form means suppose if the given PDE in this form means and it is linear means we will write in this form like dx by p capital P, dy by capital Q and dz by capital R. Okay. Then we will equate these fractions and we will find the two solutions. Okay. So that's it. First we have to see whether it's a linear first order PD or not. And if it was in this form, capital P small into small p plus capital Q into small q equal to R. So small p means dou z by dou x, small q means dou z by dou y. So capital P, capital Q, capital R functions in terms of x or y, or sometimes it may be x, y, z also. Okay. So we will write that one as dx by P equal to dy by Q equal to dz by R. These are the fractions now. These fractions, these three fractions, we will equate. That means we will equate any two fractions one time and we will find the two solutions. So then I will solve some problems. We will get clarity. Solve. Solve y square z by x p plus xz q equal to y square. So I will check once again this question. Y square z by x into small p plus xz into small q equal to y square. Okay. Next. Answer. Consider it as equation number 1. So it is of the form capital P into small p plus capital Q into small q equal to R. Okay. So here capital P is y square z by x comma capital Q is xz comma capital R is y square. See here small p coefficient is capital K, capital P, small q coefficient is capital Q, and this one right hand side part term is R. Okay. So now We will write as dx by capital P, dy by capital Q, dz by capital R. Okay. So next we will get that dx by y square z by x equal to dy by xz equal to dz by y square. Okay, na. Now we will equate first two terms. One time next first term and last term. Okay. So now I am equating first two terms, 1 comma 2 terms, first comma 2 terms. Okay. We need to check before equating. So if you equate these two fractions means z terms need to vanish out. Here dx dy is there now. Only x and y terms need to be vanish out. Then only we need to equate these two. So if you see here, z will vanish out and only xy terms will remains here. So that's why I am equating here first and second. Okay. Then first and second terms equating. So here it will become here now. It will become in numerator this x. Okay. X dx equal to y square z equal to dy by xz. Okay. This zz will vanish out. This zz will vanish out. Then you will get here. If you cross multiply means here you will get here x square dx equal to y square dy. Okay, now. So now applying integration, we'll get that integral x square dx equal to integral y square dy. Okay, now. So here we will get that x to the power of 3 by 3 equal to y power 3 by 3. Some constant will come now. That constant I am going to assume it as some a. Okay. So here we will get that x to the power of 3 minus y power 3 by 3 equal to a. Okay. Then you will get here x to the power of 3 minus y power 3 equal to 3a. I am going to assume this one x to the power of 3 minus y power 3. This 3 I am going to assume it as a dash. A dash means if you will confuse, we will assume it as some a1. Okay, we will assume it as some a1. Just to show the variation, 3a here, there is a constant. I am assuming it as that one as some a1. Okay, consider it as equation number 1. Okay, now from fractions 1 and 2 I done. Now 1 and 3 I am doing. Okay, so before equating we need to check. Okay, if you see here 1 and third term means here x and z only need to remains. All y terms need to vanish out. If we get first one and the third one, y square will vanish out and only x and z terms will remains. Okay. 1 comma 3 terms. So this x will become will go into the numerator now x dx by y square z equal to dz by y square. Okay. Here y square will vanish out. Y square will vanish out. Then here we'll get the, I'm transferring all x terms one side, all z terms one side, like variables approval. Then here you will get that x dx equal to z dz. Applying integration, then you will get integral x dx integral z dz equal to x square by 2 equal to z square by 2 plus some constant is there now. That constant some constant will come now after completion of integration. That constant I am writing it as some b. Then here you will get that x square by 2 minus z square by 2 equal to b. Then here you will get that x square minus z square equal to 2b. So x square minus z square equal to b dash. So this 2b is a constant that I am going to assume it. I am assuming it as a b dash. So otherwise, here assume at a1. Now here we'll assume as b1. Okay. So next equation number 2. Okay. So from 1 and 2, required solution is, I said already 2 solutions you will find for this type of problems. So from 1 and 2, 1 and 2, we have to write solution as pi of a1 comma b1 equal to 0. That means pi of a1 means x to the power of 3 minus y power 3, comma b means x square minus z square equal to 0. That's it. In some textbook, they given like this solution. In some textbook, they given that r a1 equal to f of b1. Okay, that means here a1 means x to the power of 3 minus y power 3 equal to f of b1 means x square minus z square. That's it. Whether if you write like this, that is also correct. If you write like this also, this is also correct. In some textbook, they given like this solution. In some textbook, they given solution like this. Both are correct only. Okay. So next I will solve one more problem. So second one, solve p square root of x square root of x plus q square root of y equal to square root of z. Okay. So assume it as equation number 1. Answer. It is of the form. It is of the form capital P small p plus capital Q small q equal to capital R. So here it is a small p and it is small q. So then here capital P is root x, comma, capital Q is root y, comma, capital R is root z. Okay. So now dx by p equal to dy by capital Q dz by capital R. Okay. So now we will get that p means square root of x, q means square root of y, r means square root of z. So here we will get that dx by square root of x, dy by square root of y equal to dz by square root of z. Okay. So now equating fractions 1 and 2, 1 and 3 will get as follows. That means before equating, we need to check that. Okay. Whenever we will equate first and second term, only x and y terms need to be there. Remaining terms need to vanish out. Okay. If you compare these two, only x and y will come. Okay. And as similarly 1/3 if you compare means only x and z are will remain. Remaining need to vanish out. Okay. So 1, 2 terms. 1, 3 terms. So see here, this one can be written as 1 by square root of x means that is x to the power of minus 1/2 dx equal to y power minus 1/2 dy. Here 1, third means x to the power of minus 1/2 dx, z to the power of minus 1/2 dz. So applying integration, here you will get that x to the power of minus 1/2 dx integral y power minus 1/2 dy. Here you will get that it is the number of x to the power of n. Then you will get here x to the power of minus 1/2 plus 1 minus 1/2 plus 1 equal to y power minus 1/2 plus 1 minus 1/2 plus 1 plus constant I am writing as a. Okay. Here also applying integration. Here you will get that x to the power of minus 1/2 dx equal to z to the power of minus 1/2 dz x to the power of minus 1/2 plus 1 minus 1/2 plus 1 equal to z to the power of minus 1/2 plus 1 minus 1/2 plus 1. Here constant will come now. That constant I am going to write it as b. Okay. So here we will get that 2. So here okay, I will write one more step. Here minus 1/2 plus 1 x to the power of 1/2 by 2 equal to y power 1/2 by 1/2 plus a. Here we will get that 2 square root of x equal to 2 square root of y plus a. So here 2 taking otherwise yeah, we'll do it later, right? So 2 is taking outside, then transferring y from right hand side to left hand side, you will get here root x minus root y equal to a. Okay. So root x minus root y equal to a by 2. So this a by 2 I am going to assume it as some a1. So root x minus root y equal to some a1. Okay. That's it. Next here, this one you can assume it as some equation number 1. Okay. So here we will get that x to the power of 1/2 by 1/2 equal to z to the power of 1/2 by 1/2 plus b. So here we will get 2 square root of x equal to 2 square root of z plus b. So transferring z term from right hand side to left hand side, we will get here 2 is also taking outside 2 square root of x minus square root of z equal to b square root of x minus square root of z equal to b by 2 square root of z square root of x minus square root of z equal to this b by 2 I am going to assume it as a b1. Consider it as equation number 2. Okay. From 1 and 2, from 1 and 2, so I am going to write a solution pi of a1 comma b1 equal to 0. That is pi of square root of x minus square root of y comma square root of x minus square root of z equal to 0, or A1 equal to pi of, here pi already used now function. So next, that's why I will use the function f next, okay? F of V1. So here, square root of x minus square root of y equal to f of V1 is square root of x minus square root of z, okay? That's it. This problem is also over. So I will give two more problems for you people to practice, okay? So for practice, people can practice. I will give two problems. This third one, solve xp plus yq equal to 3z. Next, fourth one, solve p yz plus qzx equal to xy, okay? So I will give one more problem also. Fifth one, solve y square p minus xy q equal to x into z minus 2y, okay? So for this problem, I will give hint. These two problems same as it is ditto as we solve above. For the fifth one, I will give hint like compare first equations term. We will get like first we will get like this now, dx by y square dy by xy equal to dz by x into z minus 2y, okay? First compare these two terms, 1 comma 2. Next 2 comma 3, okay na? So in 2 comma 3 hint is cross multiply d of yz equal to y dz plus z dy, okay na? So this is the hint for this problem to do, so you people can practice. So I will proceed further. So next we will discuss, there are some certain type of problems will be there. So that for that type of problems we can't find the solution directly by equating these fractions, okay na? That is known as method of multiplies. So another name also like Lagrange introduced this topic. That's why it is also known as Lagrangian multiplies. Okay, so see here. So by equating that fractions, if you are unable to find the solution, then we will use this method. So method of Lagrangian multipliers. Okay, these problems also will be in this form only, like PP in this form only. Here I shown now PP like QQ equal to capital R. These problems also will be in this form only. Okay, So we will write in this form dx by p dy by q equal to dz by r. But here up to now, what are the problems we solve, that by equating two fractions we are able to get the solution. But now what are the problems we are solving? For that problems, by equating that fractions we can't find solution. On that time we will choose the multipliers. Okay. So generally some randomly giving name as a LMN. Okay. We will find out that multipliers. How we will choose that multipliers means this LMN are known as the multipliers. Capital P, capital Q, capital R, we know that. Okay. If you do this product, if you do this product, if you do this product, it will, it must need to be equal to 0. Okay. Then we will write in this form dx by p equal to dy by q dz by r equal to L dx plus m dy plus n dz. Here L, M, n are the multipliers, Lagrangian multipliers. That also will be a functions in terms of x, y, z. Okay. Sometimes 1, 2, 3, like 1, 1, 1, like that also will come. Later, after finding these multipliers, we will get this term. We will get this term. Okay. These term we will equate with any one term. We will equate with, here three terms are, three fractions are there. Now we will equate with any one. Okay, like this. So we will choose that LP plus MQ plus NR will must need to be equal to 0. Like that, we will choose the multipliers. Okay. So see here, each term we will multiply like dx by p. Anyway, here 0 is there now in the numerator. 0 into that term will become 0. Okay. Then we will get there L dx plus N dy plus N dz. We'll get there L dx plus M dy plus N dz. Then we will apply the integration. We will get record solution. Okay. So I will solve one problem. You will get clarity. Okay. So in this Lagrangian multiplies. So in this, I will discuss problems, this topic. Yeah. Solve first one. Solve Z it came like this. Z minus y small p plus x minus z small q equal to y minus x. Okay. So equation 1, and it as equation number 1. So it is of the form capital P small p plus capital Q small q equal to R. Okay. So now We will write in this form dx by capital P, dy by capital Q equal to dz by capital R. So here small p coefficient is capital P. So it is capital P. Small q coefficient is capital Q. That is whatever the term is there here in right hand side, that is a capital R. So you people need to observe carefully. Sometimes they will give this term in left hand side also. Okay, you need to transfer the term from left hand side to right hand side. Then only you need to consider that one as a R. Okay, otherwise the symbol variation will come. So here dx p means here this one z minus y equal to dy by q. Q means this one x minus z. So dz by capital R. Capital R means y minus x. Y minus x. Okay. So if you observe clearly, previously you are able to solve by equating two fractions and we are getting two solutions. Okay. But here by equating these fractions, it's not possible to get the solution. That's why we are going to choose the multipliers. We need to get the two solution. That's why we will choose two multipliers. Okay. So here set one multipliers. Okay, it is also known as Lagrangian multipliers also. Okay, that is L comma M comma N. So L comma M comma N are 1 comma 1 comma 1. How I chosen this one means LP plus MQ plus NR need to be equal to 0. Okay, see here. If I find this one for this LHS, that means if I solve the here LP plus MQ plus NR, it will be equal to 0. So that type of terms only we need to consider it as a multipliers. Okay. So here see L means 1. Okay. Here P means Z minus Y. Z minus Z minus plus 1 into X minus Z plus 1 into Y minus X. So here Z minus Y plus X minus Z plus Y minus X. Okay na. So if you solve this one, that means XX will vanish out. XX will go. ZZ will go. YY will go. At the end 0. Okay na. So that's why here 1 1 1 are the one set of multipliers. Okay. So now LDX plus MDY plus NDZ equal to each term or any one term. Okay. E equal to any one term among 3. Okay. So LDX plus MDY plus NDZ by LP plus MQ plus NR. Okay. So LMN are the 111 1 dx plus 1 dy plus 1 dz equal to, see here, LP plus MQ plus NR, it will be equal to 0. Okay, we only choose an intentionally. Okay, this is the procedure, working procedure, equal to 0. Okay, so any one term here is same. Okay, any one term. So here 0 is there. If you transfer 0 from this side to this side, the term will become 0. Okay, so here we will get that 1 dx plus 1 dy plus 1 dz equal to 0. Now apply integration. We will get here integral 1 dx plus integral 1 dy plus integral 1 dz equal to, so it is the indefinite integral. Some constant will become na, that means one constant will come. Generally after completion of integration we will write constant. So if you write starting also no problem. Okay, writing as some a, okay, will be equal to some a. Here we will get that x plus y plus z equal to a. It is an equation one solution we got. Now for this one set of multipliers I choose. Next another one more set of multipliers also we can choose. Okay, to get the another solution. Okay, that means set two multipliers. Set two multipliers. Set two multipliers are x comma y comma z. Okay, so in this type of problem choosing multipliers only complicated. Once if you choose the multipliers, how we choose the multipliers means there is no specific rule. We need to guess that. Okay, now x y z na, so that definitely here LP plus MQ plus NR must need to be equal to 0. That is L means x into capital P means y z minus y plus M means y and Q means x minus z plus N means z and R means y minus x. Okay, so next I'm going to multiply this. Here we will get that xz minus xy plus yx minus yz plus zy minus zx. Okay, so see this one xz xz zy zy xy it is becoming 0. Okay, we only choose an intentionally. Okay, this function need to become 0, then only we need to consider it this as a multipliers. Okay, now L dx plus M dy plus N dz by LP plus MQ plus NR equal to any one term equal to any one term, any one term among three. Three terms are there now, we can equate to any one term among those three. So here L dx means here L m n means xyz. So xyz x dx plus y dy plus z dz by LP plus MQ plus NR will be equal to 0. Okay, we only choose them. Like in that way only we need to choose the multipliers. Okay, here we need to equate in any one term. Okay, so here if you multiply with the 0, okay, here in the it was in dividing. If you go this side means the right hand side, it will multiply. 0 into anything is 0. Then you will get here x dx plus y dy plus z dz equal to 0. Now applying integration, then you will get here integral over x dx plus integral over y dy plus integral over z dz. So some constant will come now here. So generally we will write after integration, but initially also you can write. Okay, no problem. That constant I am going to assume it as some p1. Okay. Here what I assume here a. Okay, here a only assume. Okay, no problem. So here why I am assuming here b1 means initially here x square by 2 plus y square by 2 z square by 2 will come na. So that here I will transfer 2 from left hand side to right hand side. Here 2b1 will come. So the 2b1 I will assume it as a b. Okay na. So here I'm assuming that this one as a b1. So here see you will get here x square by 2 plus y square by 2 plus z square by 2 equal to b1. So here we will get that x square plus y square plus z square equal to 2b1. Okay na. So this 2b1 I am going to assume it as a b. Okay. X square plus y square plus z square equal to this 2b1 I am going to assume it as b. It is as equation number 2. So we got two solutions, that is x plus y plus z equal to a, x square plus y square plus z square equal to b. Therefore from 1 and 2 the required solution is we can write it as a pi of a comma b equal to 0 or a equal to f of b. Okay. So here I am writing here pi of a comma b, that is the a is x plus y plus z comma b means x square plus y square plus z square, x square plus y square plus z square equal to 0. Or by using this one we can write a means x plus y plus z equal to f of b means x square plus y square plus z square. Okay na. So that's it. So this one also over. I will discuss one more problem. Okay. Then I will stop. Okay na. So for your practice I will give some problems for practice. Second one in this. So solve x square minus yz small p plus y square into z minus x small q equal to z square into x minus y. So hint for this hint, multipliers Set 1 multipliers are 1 by x square, comma 1 by y square, comma 1 by z square, comma set 2 multipliers are 1 by x, comma 1 by y, comma 1 by z. Next, okay, third one, I will solve third one. Please better z minus y. Already 2 times is there, one problem. Z minus y. Z minus. Okay. So one more problem also I will give for you people. Solve x into y square minus z square p plus y into z square minus x square q equal to z into x square minus y square. For this hint is set of multipliers. Set 1 1 by x, comma 1 by y, comma 1 by z. Set 2 multipliers are x, y, z. X, comma y, comma z. Okay. So I will solve one more problem, then I will end this session. Okay, these two problems note down. You people try to do. Next, fourth one. Solve x into y minus z p plus y into z minus x q equal to z into x minus y. Okay. So now answer candidate equation number 1. It is of the form. It is of the form capital P small q p plus capital Q small q equal to R. So now dx by capital P, that means x into y minus z equal to dy by y into z minus x equal to dz by z into x minus y. So if you observe here clearly, by equating any two fractions, we can't do. Then you have to go for method of multiplies. We have to choose the multiplies. Okay. So here one set of multiplier, choosing that set one multipliers 1 by x, comma 1 by y, comma 1 by z. Okay. So here LP plus MQ plus NR equal to L is 1 by x, P is x into y minus z plus 1 by y, Q means y into z minus x plus 1 by z into x minus 5. Okay, na. So see here you will get that xx will vanish out, y minus z plus z minus x plus x minus y. Here xx will vanish out, z will vanish out, y will vanish out, remaining we will get that 0. That means here LP plus MQ plus NR is equating to 0. That means 1 by x plus 1 by y, 1 by x comma 1 by y, 1 by z are the multipliers. Okay. So our aim is that one only. LP plus MQ plus NR need to be equal to 0. Okay. Then LP next LP plus LDX plus MDY plus NDZ by LP plus MQ plus NR equal to any one term among three. So here three terms are there, na? So we will equate with any one. Okay. Here we will get that LDX, that means 1 by x dx plus 1 by y dy plus 1 by z dz. So we know very well that LP plus MQ plus NR will become 0, equal to 0. So this is any one term we will equate. Okay. So here 0 into the term will become 0. Here we will get that 1 by x dx plus 1 by y dy plus 1 by z dz equal to 0. Applying integration, then you will get here integral 1 by x dx plus integral 1 by y dy plus integral 1 by z dz equal to here the result will come in terms of log, na. That's why here I am writing constant as a log a. So here we will get that log x plus log y plus log z equal to log a. So log a plus log b plus log c can be written as log abc. So here we will get that log xyz equal to log a. That means xy z equal to a. So it is a solution 1. Next, and another one solution we will find by using set 2 constraint. Set 1 constraint are 1 by x plus 1 by y 1 by z. Next, set 2 constraint are set 2 constraints multipliers will choose as 1 comma 1 comma 1. Okay. So LP plus MQ plus NR equal to 0. Here L is 1, M is 1, N is 1. 1. P is, what is P? X into Y minus Z. X into Y minus Z plus M. M is 1. So uh, Q is Y into Z minus X. Y into Z minus X plus 1 into, here capital R, na capital R, Z into X minus 5. Okay. So here we will get that XY minus XZ plus YZ minus XY plus ZX minus ZY. So XY will vanish out, XZ will vanish out, YZ will vanish out. It is equal to 0. Okay, that means 1, 1, 1 are the multipliers, Lagrangian multipliers. Okay, it must need to be equal to 0, LP plus MQ plus NR. Okay, suppose it was not becoming 0 means we need to go for another. That means it's like a trial and error form only. There is no specific rule to find out these multipliers. Okay, next. L dx plus M dy plus N dz by LP plus MQ plus NR equal to any one among 3, equal to any one among 3 terms, among 3 terms. Okay, LMNR 1. Okay, 1 dx plus 1 dy plus 1 dz by 0. LPMQ plus NR will become 0. Now only I shown above, equal to any one term. Among 3 fractions are there na, so any one fraction. Okay, so 0 into that term, it will become 0. Here we will get that 1 dx plus 1 dy plus 1 dz equal to 0. Applying integration, here we will get that integral 1 dx plus integral 1 dy plus integral 1 dz equal to this constant. I am writing it as here b. So here we will get that x plus y plus z equal to b. This is a solution 2. From 1 and 2, required solution is from 1 and 2. So here, there what we got? X, Y, Z in product, I think. Okay, yes, X, Y, Z equal to A. Okay. So you can write it as pi of A comma B equal to 0 or A equal to F of B. Both are correct. If you write like this, both are correct only. So pi of X, Y, Z comma X plus Y plus Z equal to 0 or X, Y, Z equal to F of B means X plus Y plus Z. That's it. Okay. So yeah, that's it. Your syllabus is over. I will stop the recording. If you want to ask anything means you can ask me.